Hello, I am Priyanka Chakraborty. In my previous video, I was discussing about the full wave rectifier, half wave rectifier, and the calculation of average current, RMS current, ripple factor, etc. So today, I am going to discussing about filter. So actually, the output voltage of a rectifier is a pulsating DC voltage, which consists of DC as well as AC components. Due to the presence of AC components, ripple exists in the output voltage. So to get a smooth DC output voltage, the AC components must be removed. This is only possible by using filter. Here, a full wave rectified output voltage is used as an input of a filter, and the output voltage of the filter is a DC voltage with very less ripple. The filter is a circuit used to remove the unwanted AC components from the rectified output voltage, allowing the passage of only DC components. Usually, a filter contains inductors, capacitors, resistances. The filter operation depends on the properties and the values of passive circuit elements. The inductors allows the passage of DC signal and block the AC signal. On the other hand, the capacitor allows the AC signal and block the DC signal. So here, this is the AC input supply voltage. This is the input signal, this one. This is the rectified output. Here we use the bridge rectifier. So this is the bridge rectified output. Here we use filters circuit. So this is the filter output, where there is no AC component present in the output waveform. Actually, there are 4 types of filter. There are series inductor filter, shunt capacitor filter, LC filter, that is inductance and capacitance filter, and pi filter. So for series inductor filter, this is the circuit diagram. Here we use a inductance and a resistance RL. So in this type of filter, inductor or choke L is placed between the rectifier and the load resistance RL. The rectifier output voltage contains DC as well as AC components. If the AC signal is passed through an inductor, it provides high impedance and consequently blocks the AC signal. When a DC signal is passed through an inductor, it provides very low impedance and allows the passage of DC signal. So this is the output waveform of series inductor filter. This one is the rectified output, that is without filter, and this one is the filter output, that is with choke filter. So this is the operation of series inductor filter. For shunt capacitor filter, this is a circuit diagram where we use a capacitor and a load resistance R. So to define the operation, first of all, I consider this one is A, this one is B, this one is C, this one is D, and this is E. Okay. So during the positive half cycle of the AC input, the diode of the rectifier is forward biased, so it is conductive. This quickly charges the capacitor to peak value of the supply voltage because of almost zero charging time constant. So this is shown by the point B, this portion. After being fully charged, the capacitor holds the charge till input AC supply to the rectifier goes negative. During the negative half cycle, the diode gets reverse biased and so stop conduction. So the capacitor discharges through load resistance R. Okay. Because of large discharge time constant RC, the capacitor does not have sufficient time to discharge appreciably. Due to this fact, the capacitor maintains a sufficiently large voltage across R even during the negative half cycle of input signal supply. So during the next positive half cycle, when the rectified voltage exceeds the capacitor voltage represented by point C, this one. So the capacitor again charged quickly to the maximum voltage, that is represented by point D. This is this portion. So the process of charging and discharging of capacitor is repeated for each cycle of the input supply voltage. So this is the working principle of shunt capacitor filter. This is the waveform. This is the AC input signal. This is the rectified output. And this is the filter output where the charging and discharging happen. Okay. So next is LC filter. In case of LC filter, actually this is a circuit diagram where we use inductance and capacitance and the resistance RL. So it consists of a inductor L connected in series with a rectifier and a capacitor C across the load. This is also called L section filter because in this arrangement, inductor and capacitor are connected as an inverted L. The choke L on input side of the filter allows DC to pass but opposes the flows of AC components because its DC resistance is negligibly small, but AC impedance is large. Any fluctuation that remains in the current even after passing through the choke are largely bypassed around the load by shunt capacitor. Okay, so this is the output waveform of LC filter. This is the output waveform of LC filter. This is the rectified output, the red portion, and these blue lines, that is the filtered output. Okay. So now, next and the last one is pi filter. So this is the circuit diagram of pi filter. Here we use two capacitance and one inductance. Actually, this circuit looks like a symbol pi. That's why it is called pi filter. So it consists of two capacitances. That is, one is C1 and another is C2 and the inductor L. The output voltage of rectifier is fed to the input terminals of pi filter circuit. The capacitor C1 provides a low reactance to the AC components as it passes a certain amount of AC component to the ground. The capacitor C1 provides very high resistance to the DC component. The DC components pass and flow through the inductor. The inductor L provides a high impedance to AC components and very low impedance to the DC components. The DC components passes through, but it blocks the AC components. The capacitor C2 operates in the similar way of the capacitor C1 and it can pass the AC components. Therefore, the DC components is available at the output terminal. So, this is the working principle of pi filter. This light violet portion is the rectified output and this deep violet line is the filtered output. Okay. So that's all for today. If you like my videos, please subscribe my channel. So if you have any questions, please drop it in my comment box. So thank you and goodbye. Stay safe.